point here. Pew. So on this guy, please try to attempt this one. It's very, very important that you're able to evaluate and derive the result being root 3 minus root 2. It's very, very important for you to be able to derive that. Okay, so now let's have a look at the quotient form. Integration with quotient is going to be very important. And for the first one, the f prime over f, we already have looked at it, right? But then we're going to talk about the quadratic form as well as the polynomial quotient, which we can use the long division, or which we can also have to do with the partial fraction. Remember, the partial fraction has been added to the new surface. And the whole point of adding the partial fraction is that so that they can expand working with the integration. Okay? So, oh my god, the Zoom is only 40 minutes? Wow, that really sucks. Anyways, so you know, when we have f prime over f, we can convert that into the logarithmic form, and we saw a great example of those with, what is it, tangent, cotangent, and secant. Please do remember the integrals of such. But now let's have a look at the case with the quadratic. And as you guys know, the quadratic has two cases, whether it can be factorized or not non-factorizable cases. For the non-factorizable cases with the quadratic, what we used to do is the completing the square, right? Well, what we're going to have a look at is the factorizable cases. And for that, we're going to use this partial fraction method for the product of the two AB, okay? You should try yourself whether this really works or not. It does, okay? So if your quadratic form is factorizable, you see, it is factorizable. It's going to be the product of x plus 3 and x minus 2. And what we're going to do is to use this partial fraction, right? And if you do so, the if I let the b to be x plus 3, for example, then b minus a is going to be 5. So 1 over 5 comes up, and then the difference of 1 over a and 1 over b. Voila. 5 cancels out, and now I am only left with the integral of a rational function, which you know, the integral of a rational function becomes a logarithmic function. So hence, it's going to be ln x plus 3 minus ln x minus 2, where by the laws of log, the difference becomes the quotient, as you can see. So far, so good. But obviously, you know, the more interesting example will be something to do with who? Completing the square, right? The more interesting thing will be something to do with the completing the square. And for those, I want you to remember two forms. The antiderivative of the 1 over a squared plus x squared, which is our arctangent, and then the arcsine here. I really beg you to know, to distinguish for the arctangent, if it's a squared, the constant here, 1 over a is going to come out. But for the a squared, the perfect square of within the square root, it does not come out for the arcsine. Okay, make sure you are able to distinguish that. Okay, so let us have a look at the 1 over 1 plus 9x squared, right? And my job here is to describe this as a sum of the squares, right? And from this table, you know, for this problem, what do you think you're going to have? Can you please tell me what you think you're going to have? Would you have something of arctangent or arcsine? But while you guys answering that, can I quickly go get some water? I'm going to grab some water. Hold on a sec. Just give me 1 second. I'm back with 4 bottles of water. Yes, thank you, Songi, for participation. You get the arctangent, right? So, you know, my domain here is going to be 1 over 3. But here's the thing. This 1/3 did not come from there. If I quickly remind you, remember that the for the integration with the computing the square, I want you to consider two things. Yes, something about the a squared plus x squared is going to give you 1 over a for the arctangent, yes. However, also, there's a cases of what? Of the linear sub, right? If I know his antiderivative, it's going to be just written as the capital letter F, ax plus b, right? However, 1 over a also needs to be multiplied by precisely the integration by substitution, right? So make sure these two has to be considered. So let me show you what I mean by that, right? So for him, you know, the square root of something of a quadratic form is very likely that it's going to associate with the completing the square. So if I attempt to put it into the completing the square, voila, I have such form, okay? And from here, what I have then is that I can put it as a perfect square, and this reminds me of what is it? The arc sine. But here are a few things that I have to consider. I have a square from the antiderivative of to associate with the arc sine, but I also have the linear sub. So what I'm having the dilemma of here is who is going to come out? Will 1 over 3 come out from the antiderivative with the inverse trick, or 1 over 2 comes out for the linear sub? What do you think? In your opinion, who is going to pop out? Can you please tell me in our YouTube chat, please? Who is going to pop out? Both of them? Do you think 1 over 3 and 1 over 2 will pop out? Or do you think only 1 over 3 or only half will pop out? Unfortunately, only one of them pops out. Who is the 2? 1 over 2 will pop out. Why? Because remember, if I remind you about the identity here, as you can see, a squared 1 over a doesn't come out for the arc sine. However, nevertheless, he has who? He's got the linear sub 2x, right? So 1 over 2 will come out. However, remember, 1 over 3 does not come out for, oh, thank you, Yuri. Oh, sorry, no, 1 over 3 does not come out, right? Only 1 over 2 comes out. But thank you very much for the participation. That's all I want from you guys, okay? Good job. Right, so, you know, I can just talk about hodgepodge, you know, for example, you know, suppose, let's say I try with the square root of 5 squared minus 2x plus 1 squared. And yes, you know, I know it's going to be something of an arc sine. No problem, it's going to be arc sine, and the domain here is going to be 2x plus 1. My a is going to be 5, the constant square, but in the front, who comes out? That depends on either its inverse sine or inverse tangent. But for the inverse sine, I know 1 over 5 does not come out. But instead, only half is going to come out. But you know what? The situation is quite different for the arctangent. Because what we have seen, so suppose, you know, I took out the square root and made it as a sum of a perfect square, you see? If that was the case, I then know that who is going to pop out? 1 over 5 is going to pop out, and 1 over 2 is going to pop out, and then the arctangent of the domain 2x plus 1 over 5 is going to be what it is, right? That, my friend, is going to be your expression here, you see? So it depends whether it's an inverse sine or inverse tangent, who is going to pop up. So you got to be very careful with that. It can only be distinguished quickly through practice.